Hi guys, welcome to question 2. We're busy with the November 2012 Namibian Higher Level Mathematics paper 2. Okay, this is question 2 and this is just two parts, 2a and 2b, and all we have to do is differentiate two functions. Okay, so let's start with the basic idea of differentiation. If we have a function f of x and we say that function is equal to ax to the power n. If we want to differentiate that function, what we do is we say take the exponent multiplied with the coefficient, so we get n times a, x to the power, and then we subtract 1 from the exponent, so x to the power n minus 1. So that's the basic idea how we do differentiation. Differentiation is why we do this. Alright, and that's exactly what we want to use. So let's start with question A. Question A, we start with, I'm going to rewrite the whole thing in case you can't see that very well. So y equals, and we get the cube root of x to the power 4 over 2 plus 5x. And now we have to differentiate this. First thing we want to do is we want to rewrite it so we get it in normal polynomial form. So get rid of the roots, get rid of x's below the line. We just want it in the form of like ax to the power n plus bx to the power m plus cx to the power d, etc. Right, this kind of form. So that's exactly what we want to do. So we can say this, let me just go over some of the exponent rules again. If we have that, we can rewrite that as a to the power inside over outside. Right, maybe just one more time in case that was too ugly the handwriting. Let's call that a b and a c. So we can rewrite this as a to the power inside over outside. Okay, hopefully that helps. So let's apply that. So this part we can rewrite as x to the power inside, which is 4, over outside, which is 3. All of this still over 2 plus 5x. 5x is fine as it is. Now you could also choose to write this, instead of having x to the power 4 over 3 all over 2, you could also write that as a half x to the power 4 over 3. Right, that'll be perfectly fine. I actually think most people prefer that. So let me also write it that way. Let me also write it that way. So one more time, we're going to say this is just a half, right? 1 over 2. So 1 over 2 x to the power 4 over 3 plus 5x. So all we did so far is rewrite the original equation in an ax to the power n plus bx to the power m kind of form. Now we can actually start the differentiation, and that's when we put the little dash. That means this is the derivative of the previous function. Okay, so we said we take the exponent multiplied with the coefficient. So 4 over 3 times 1 over 2 gives us 4 over 6, which we can simplify to 2 over 3 x, and then we subtract 1 from the exponent. So 4 over 3 minus 1 is 1 over 3. Well, that's an ugly 3. 1 over 3 plus, and now here we do the same thing. This exponent here is a 1, so 1 times 5 is 5, and then we put x, and then we say the power of 1 minus 1 is 0. But what is x to the power 0? X to the power 0 is just 1, so that's why we can say the x falls away, right? So we don't, sorry for that. So we don't actually say the x falls away, but that's sort of the impression we can get, and we can use that loosely. If we have a straight line like this, 5x, and we differentiate that, we just have the constant left. Okay, and that is done. Right? That is the derivative of the first part. Let's look at question B. Question B, again, I'm going to rewrite the whole question. So y equals x cubed minus 4x squared, all of that over x to the power 4. Now this one I'm going to do it two different ways. Option 1. Option 1 is we split this up into two fractions. So we can say this is x to the power 3 over x to the power 4 minus, and then 4x squared over x to the power 4. Then we can simplify that. So x cubed and x to the power 4, the x cubes cancel out with 3 of those x's, so we just have 1 over x here, minus the 4 can stay, but the x squared cancels out with 2 of those, so there's just an x squared left at the bottom. Now we don't want x's at the bottom, so we rewrite it one more time by taking these x's to the top. So what happens if we take some value from the top to the bottom, or from the bottom to the top? The exponent sign change. So now we have 1 times x, and this exponent was 1 at the bottom, so at the top it will be negative 1. Alright, and now here we've got minus, the 4 can stay. We have to take the x to the top, so the exponent changes signs from positive 2 to negative 2. Great, so now we have it in this normal form. Something x to the power something plus something x to the power something, etc. So we can actually do our differentiation. So the exponent times the coefficient, so negative 1 times 1 gives us negative 1 x, and then negative 1, we subtract 1 from there, which gives us negative 2. Great. And we do the same with the next part. Negative 2 times negative 4 gives us plus 8 x, and then we subtract 1 from negative 2, which gives us negative 3. Now we're almost done, but we're not allowed to leave our answer with negative exponents. So all we need to do is rewrite this so the exponents are positive. Okay, so to change the sign of an exponent, the variable has to go to the other side of the line, so to speak. So we can keep the negative 1, but the x squared, or the x to the power negative 2, has to go to the bottom. Then this negative 2 changes to positive 2. Same on this side, we can keep the 8. The x to the power negative 3 has to go to the bottom to become x to the power positive 3. And there's our answer. Now option 2 will just be slightly different for the first step or two, and from there it'll be exactly the same. So we're going to just use this until we get to this line. As soon as it looks like this, we know how to go from there, right? Okay, so with this one, I will start off by multiplying, or by taking this thing to the other side of the line. So we're going to say y equals x cubed minus 4x squared. But instead of writing over x to the power 4, we take the x to the power 4 at the top, and then it becomes x to the power negative 4. Right, what do we do from here? Well, if we're multiplying and the bases are the same, then we add the exponents. So we've got an x here, and we've got negative 3 plus positive 3 plus negative 4 gives us negative 1. Then we've got minus 4x, and then 2 plus negative 4 is negative 2. So we see already we're right at this step, and from here we just differentiate. Okay, good. So that was the basic idea for question 2, and join me again soon for question 3.